The first question is the firm's unconstrained profit maximization problem, while the second part is the constrained cost minimization problem. The first order condition of the profit maximum is that the first derivative of the profit with respect to input is equal to 0. The second order condition of the profit maximum is that the Hessian matrix of the profit function is negative definite. In a two-input case, where n is equal to 2, a negative definite Hessian matrix means pi sub 1, 1 is negative, pi sub 2, 2 is negative, and pi sub 1, 1 times pi sub 2, 2 minus pi sub 1, 2 square is positive. For question 3, we need 2 steps to prove the output supply curve slopes upwards. The first step is to show that partial pi partial p is equal to output f, which is the first part of the Hotelling's lemma, and we have done this in the class. The second step is to show that the profit function pi is convex in P, which is the result of question 5. So we can use the result of question 5. The second derivative of pi with respect to P is positive. Then we replace partial pi over partial P with output f. This will lead to partial f over partial p is positive. Remember that f is the output, so it means output increases with output price p. In other words, output supply curve slopes upwards. In question 4, we are required to prove the second part of the Hotelling's lemma. We use the same technique when we prove the first part of the Hotelling's lemma. Keep in mind that x or x's are function of output price P and input price is W. Now we are holding P constant and take the derivative with respect to Wi. We can cancel many terms using the first order condition. Finally, we obtain minus xi star, which is negative. So profit is non-increasing in input price Wi. For the next question, we can use the definition of convexity to prove it. Here we are holding input price W constant. The key is that under a certain price system, there's only one input combination that can maximize profit. Another way to show the profit is convex in output price P is to use a graph. When the output price increases from P1 to P2, if we do nothing, the profit will increase to point A. For example, when the output price double and we do nothing, which means the output quantity remains the same, then the profit will double. But actually, the firm will do something. It will adjust its inputs and increase its output to maximize its profit. So the profit will be more than double. It will be higher than point A. It could be at the point A prime. By the same logic, we can also show that profit is convex in input price W, holding output price P constant. We use this result in question 6. The second derivative of profit with respect to input price W is positive. And we also use the second part of the Hotelling's lemma. Partial pi over partial W is equal to minus xi star. Combining these two results give us the slope of the input demand, partial xi over partial wi, which is negative. It means the factor demand is downward sloping. For question 8, we use Young's theorem and Hotelling's lemma to prove that the cross-price effects are the same. For question 11, we can show that a convex production function can also satisfy the second order condition for constraint minimum. The second order condition for constraint minimum is that the level curve, the isoquant here, is convex to origin, or the production function is quasi-concave. So if I can find a production function which is convex, and this convex production function can lead to a convex to origin level curve, then the statement is false.